All right, let's look at a couple of more harder trigonometric equations. Here's the first one. We want to come up with the general solutions. I just put in general solutions because you must come up with the specific interval solution before the general solution anyways, so we can actually do two things at once. All right, the first thing I want you to notice is that this is not written in a typical form of a trigonometric equation. What you're used to is the single trigonometric term, but now you got a quadratic within the trigonometric. But don't be afraid. So basically treat the square term, so tan x and tan x, treat it as if you were written it as this: 2y squared plus y minus 1 equals to 0. Okay, so basically you're treating it as tan of x equals to y. You're just substituting it like that. Okay, and you know how to solve this quadratic. Okay, how would you solve this quadratic? You can use quadratic formula, or you can do factoring. But I think you're pretty good at factoring, so you can factor that to y minus 1, and the next one will be y plus 1, and set that equal to 0. And then you can go ahead and solve, right? And that's exactly what we're going to do. So in this case, y is your tan theta. So we can replace that. We say 2 tan x minus 1, and then tan of x minus plus 1. And if you expand and distribute, you will get the same equation back. Now set that equal to 0. Now we got to go ahead and use a zero product rule. So this one will be either 2 tan x minus 1 must be equal to 0, or tan x equals to, or tan x plus 1, let's not bypass any steps, here we go, equals to that. Great, let's solve each one of these ones. So this one we're just solving for tan of x, so tan of x equals to half. Okay, and then the next one will be tan x equals to -1. Great, now we're going to go through and solve each of these two equations. Now remember your cast again. Okay, tangent is positive in what quadrant? The positive tangent is in quadrant 1 and 3. Okay, that's the positive for tangent. All right, so when you go ahead, now you can just go ahead and take out your calculator. So when you punch the value in, you will get 0.636. That's the tan inverse of 0.5, and that's what you will get. So this is the part where you have to basically find out, okay, this is your first quadrant right here. This is where the angle 0.46365 is. It's actually exaggerated. But the second angle in quadrant, so this is your first standard position angle. The next one has to be in quadrant 3, but it has the same reference angle as 0.46365. So how would you get that angle for theta 2? So theta 2 will end up being pi plus 0.46365, and that will give you 3.605. Okay, those are the two angles for that we just got. Great, now we're going to go ahead and do the general term on that. So theta 1 will end up being 0.46365. Now let's actually truncate that to 2 decimal just for simplicity's sake, plus n pi. Okay, and again n belongs to the integer values, okay, number set, and theta 2 is 3.605, and in this case let's change it to 2 decimal or 2 values. That's good, plus n pi again, and it's the same idea. So those two are the general solution for the first equation. Now we're going to go ahead and deal with the second equation. This is the second equation. So far what we have done, everything that we have done is only belongs to the first equation. Okay, let's go to the second equation, and that would be straightforward. Okay, our second equation was tan of x equals to -1. It's right here. This is our second equation right there, so we have to solve that. Here it is. You take the inverse of that, you get 0.785, that's negative, and quickly sketch that. And where is that? Well, the negative angle, that means in quadrant 4, that's the angle that you just got right here, okay? But we need a positive coterminal angle to that. So if this is negative 0.785, we need this angle, and that would be, so first angle theta 1 will be 2 pi minus 0.785, and that angle will end up being 5.498. Let's leave it like that for now. All right, and then what is theta 2? The theta 2, remember, it's in second quadrant. That means this is the angle that we want, but it must have the same reference angle as 0.785. So what is that? So theta 2 is pi minus 0.785 again, and in this case what we will have is 2.359. Now you can actually say, okay, in first we can truncate it to 2 decimal expansion if you want, or leave it as that. Okay, and then what is the general term for each one? Excellent. So theta 1, the general solution for that will be 5.498 plus, now this is tangent, n pi. Okay, theta 2 will be 2.359 plus n pi, and n belongs to integer number system. Excellent. Done. So how many solutions did this equation, the original equation that we started with, had? Okay, we had 2 solutions for the first equation, tan of x equal to half. This is the first two, and then the other 2 is down here. And to make sure that you understand, there are 4 possible solutions. There are 4 solutions to this equation, and that's what that is. Excellent.